by the name of the god. Design of water structure. Dams. Definition of dams. Dams are water structures that are built in canals for the purposes of storing water. Hydrograph is a curve that shows the amount of discharge passing through the river over time. And there are several shapes like that and that. For flash flood, it is one of the type of floods in which large quantities of incoming river water are formed within a short period of time. Short period of time. It's very important. Dams classification according to reservoir type, the storage, field annual over year, with diverge. Purpose, flood control, irrigation, land reclamation, electric power generation, navigation, storage, tourism. Dam height, low or medium or high. Hydraulic type, overflow dam و never overflow dam. Dam material ممكن plain concrete, reinforcement concrete, earth, rock, steel, temper. Dam type في earth, fill, rock fill, gravity, arch, buttress and so on. Classification of dams. Due to storage dams, due to height, due to hydraulic designs, due to material of construction. According to storage dams, في annual storage or long-term storage, two types. According to height, there is three types: low height, medium height, high height. For low height, H less than or equal 15 meter. For medium height, between 15 and 90 meter. H is bigger than 15 meter and less than or equal 90 meter. High height, H bigger than 90 meter. According to hydraulic design, overflow dam and non-overflow dam. That's appear in shape. According to construction, arch dam, gravity dam, earth dam, embankment dam, rock fill dam, buttress dam. Purposes of construction: dams, storage dams, flood control, power generation, river regulation, saving sets. Factors affected or affecting choose of dam type: cost, topography, geological conditions, material of construction, required heights. Investigation to choose dams: engineering survey, choosing the right places to build dams. Geological study, to study the type of the soil under the body of the dam and to study the permeability of different soil type. 3. Hydrological study to predict the amount of water that will be stored from the flood, as well as storage loss also. Types of earth dams: homogeneous embankment dams, zoned embankment dams, diaphragm dams. Force affecting gravity dams: on weight of dam, static pressure in upstream and static pressure in downstream, water weight, silt pressure, uplift force, wind force, wave force, earthquakes. It's 80 items. It's very important to study it. Percussion for saving dams. Relieve wells to reduce pressure under the dam body. This means reduce uplift force. Cut off. It is work like sheet pile to increase the length of the water path through soil under dam. الكور to reduce water movement through dam body. Water tight material to prevent water to enter to the dam body. A filter to allow water to enter to dam body but without leaving soil particles. Types of failure in dams: hydraulic failure, an overspilling or overtopping; seepage failure, seepage through dams or seepage through foundation; structure failure بيبقى sliding, overturning, settlement, instability of slopes. Environmental effect of the dams: submerging large area of the land, the height of the groundwater level, reserve the silt with the flood water, changing the nature of the climate. It affects the life cycle of some organisms. For fishway, it is facility that is built next to the dam to ensure the continuation of the movement of aquatic life along the river. Thank you. For fish, elevation from downstream to the upstream reservoir level, rotary valve assembly. Fish attracted by controlled stream flow enter slowly, providing rotary valve. We noted that the direction of move of fish against the directions of flow. It's a very important point. This shape for fishway at the dam site. A photograph for fishway at a dam site. Layout of Alamandara Arch Dam. Layout of Alamandara Arch Dam. A view of a gravity overflow dam. A view of a gravity overflow dam from the downstream side. Concrete gravity dam. Problems which appear with a dam construction. 1. Submergence problem for area covered by reservoir. 2. Fish problem of not allowing fish to pass fairly via and opposite. 3. Flood problem for not taking all possible acting forces into consideration. Bomb problem resulting damage that the wave may cause. Selection of dam type. Preliminary studies plus cost estimates for several types equal right choice. Right choice equal right type plus right location. Required data. Hydrological data. Maximum storage, normal storage, DD storage, reservoir water surface elevation, flood hydrograph. 2. Required capacity of power plant. Topography, geology, climate, soil testing, geotechnical data, material testing. storage and reservoir levels for red color cannot be stored for later use. ده الماكسيمم reservoir level. Full storage by blue line, blue color blue here. For yellow color, this means dead storage. Limit of power station head for power station. Yeah. Economic dam height. It is found at the location which corresponding to cost of dam over storage capacity equal minimum. Then economic height of the dam is the highest height corresponding to both cost of dam over storage capacity equal minimum, benefit over cost ratio more than 1. Look at the graphics. Elevation capacity curve and elevation area curve. The relation between elevation H and volume capacity third meter, reservoir surface area square meter, relation between them like that. This A curve. For B curve, relation between dam cost and elevation H by meter with dam cost by dollar. Dam cost is estimated for value of elevation. The curve gives the relation between elevation and the dam cost. That's clear. Curve C, vertical A or vertical axis is determined from curve A and B. Minimum value on y-axis shows the economic dam height on x-axis. Excellent. Example, the construction cost for certain possible heights of a dam at a given site have been estimated and are tabulated below. The storage capacity corresponding to each height is also given. Determine the most economical height of the dam. There is a table including dam height, construction costs, with storage capacity. Okay. Cost over storage in table, then draw relation between cost over storage due to dam height, the minimum height or the most economical height of the dam equal 35 meter. Hydrograph. Determination of reservoir capacity. Types of reservoir: flood control reservoir, storage reservoir. Hydrograph is the relation between time and discharge at a certain location on stream. There is one hydrographic year relation between Q or H due to time, or hydrograph of stream for many years at a certain location. There is a relation between discharge or elevation due to time. There is a curve for flood control reservoirs, inflow equal outflow. Area below inflow curve equal area below outflow curve. A equal B plus C. flood control reservoir inflow equal outflow، يبقى area below inflow curve equal area below outflow curve. A equal B due to that. This is due to hydrograph. Example: the monthly rainfall record of a flood control reservoir and the required outflow from the same reservoir are given in the following table. Month for year and monthly discharge and monthly outflow. It is required to plot the inflow hydrograph, determine the maximum reservoir storage. We draw relation between Q and month. There is two curves like that for reservoir storage. We arrived to S1 and S2. Before S1 there is evacuation. Before S2 there is storage. After S2 evacuation. For this reason we take S2 because before it is storage. Benefits of routing. Example for reservoir storage. Demand from an over-year storage reservoir 80 multiply 10 80 by 1000 m³ per second per year. Maximum reservoir storage 120 multiply cubic 10 meter cubic per second per year. There is year from 81 to 92 inflow storage spillway. Look, inflow, we reduce 80 for the first year, the storage equal 20. For year 1982, 120 minus 80 equal 40, and so on, etc. There is a value for spillway. There is a value for spillway. More than 120, this is charged for spillway. Maximum reservoir storage. Okay. Is a curve for accumulation of discharge varies time, of course. There is a relation between inflow and the time. Cumulative discharge equal inflow multiply time equal volume. Like that. Here, reservoir full start for day period. Here, reservoir full again. Here, maximum reservoir capacity, etc. We plan triangular like that, 1 year with demand or required outflow like that. Example, year from 1972 to 1979, runoff by centimeter. If the catchment area of the reservoir 1675 square meter, it is required to plot the mass inflow curve, determine the average yield from the catchment area, Determine the maximum reservoir storage capacity if the average annual demand is 2079 multiplications 10 squared multiply 10 square multiply 10 square meter cubic meter. In which years is the reservoir full and in which years it is empty. Determine the spillway capacity. Solution here, we put here runoff by centimeter, then runoff cubic meter, then you can investigate volume. For this reason we can calculate S1 maximum storage capacity and SW اللي هي maximum spillway capacity by cubic meter. We can draw it relations between Q and time as a year and draw this curve.